Question number 1. Which is the most stable among the given carbanions? Carbanion is where a carbon has a negative charge. We have not seen chemical bonding yet. Okay. So chemical bonding we could be able to say hybridization itself. Okay. At this point, let's put it this way. When you have S character, so we have seen this before, S character is proportional to electronegativity. Electronegativity is proportional to stability of an anion. Why that is? Because if suppose, let's say an atom, carbon itself has a negative sign, okay, it is attached to an electronegative atom. It can pull electrons towards it. So this negative charge is pulled inside, dispersed, meaning stability adhigamagum. Okay. Alright. Now at this point, let's just crudely calculate hybridization. We will do it in detail when we go to chemical bonding. So for hybridization, just this is enough. You want to count your number of orbitals taking part in hybridization. Okay, that will be equal to number of lone pair plus number of bond pair electrons. Okay, bond pairs, not electrons, bond pair. Okay, now you are not going to look into pi bonds. I'll do it with an example. First one, in the carbon எடுத்தீங்க அப்படினா இதுக்கு ஒரு lone pair இங்க இருக்கு, ஒரு sigma bond இருக்கு, ரெண்டு pi bond. So it has one lone pair and one sigma bond. That's 2. 2 means sp hybridization. Okay. Now this is C6H5 minus. In the carbon எடுத்துக்கிட்டீங்கன்னா, okay, it has one sigma bond, one pi bond, one lone pair. So ரெண்டு sigma bond, ஒரு lone pair. 2 sigma plus 1 lone pair equals 3. So S is 1, P is 2, 2 plus 1 is 3. When you take this one, this carbon has a sigma bond here, a sigma bond with this hydrogen and one lone pair. So I have 2 sigma plus 1 lone pair equals 3, that's sp2. You take this carbon, it has 1 sigma here, 2 sigmas with 2 hydrogen, 1 lone pair. So it has 3 sigma plus a lone pair equals 4. S1, P3, total is 4. So S character is proportional to electronegativity. So when you look at here, this is 50% S character. And ரெண்டு orbitals one S, one P. அப்ப இது 50%, இது 50%. This is sp2, this is sp2. So in sp, S character is 50%. sp2 அப்படின்னா 3 orbital ஒன்னே ஒண்ணுதான். So roughly 33.3% S character. sp3 எடுத்தீங்கன்னா 4 orbital ஒன்னு, so 25% S character. So the stability of an anion would be sp better than sp2 better than sp3. So your option is going to be alpha, which is the most stable. Okay. Now this comes down to your Huckel's rule. Okay, I will do this separately as well someday. Now look at this negative charge, it's in resonance, correct? Double, single, lone pair. So this is in resonance, so this is stabilized. This is also in resonance, okay, but this is better because it's in resonance with this double bond, or what you can do is this bond can go here and this can go here, extended conjugation. Okay, so 2 is better than 3. Now when you look here, 4 is not good at all because this is not in conjugation with the double bond. Single ஒரு lone pair பக்கத்துல single bond இருக்கு, அடுத்தே double bond வேணும், இல்ல அடுத்தது single bond இருக்கு. So this has no resonance, this has resonance, this has even better resonance. When you take this one, see, lone pair, single, double, single, double, single. So it's perfectly in resonance just like this one. So ரெண்டுமே ஈக்குவலா தான் இருக்கணும். Okay, but this has more resonating structures, but this one has, by going this electron inside, what you have is 4n plus 2 pi electrons, where n equals 1. For 6 pi electron, 2, 4, 6. 6 pi electrons, so this is aromatic. So this is the most stable. The stability order would be 1 is the best, followed by 2 because lot of resonating structures, better than 3, better than 4. Okay. Among the following, the most basic is, so let's draw each of them. Para-nitroaniline. So this is our aniline. Okay, this is para-nitroaniline. Acetanilide. Aniline, acetanilide is something that is CH3, COCH3. Next is aniline, third one is aniline, fourth is benzylamine. Third, let's just for namesake, we'll draw this one. Alright, now when you look at it, let's take aniline as our standard here. Aniline kuda in the lone pair taranuna, what type of effect that you want? Basicity means proportional to plus R group, inversely proportional to minus R. So I know that 1 is not as good as 3. So I know 3 is greater than 1. Acetanilide, when you look at it, this lone pair is in conjugation just like aniline. Okay, so basicity is less than ammonia. Not only that, this lone pair is also in conjugation with this C double bond O. So it's going to pull electrons inside. So I know my 3 is greater than 2. Between 1 and 2 we will see later. We are just going to find most basic. The most basic. When you look at here, this is not an aromatic amine. This is just aliphatic amine with an aromatic ring on the substituent. So this is going to be a 1 degree amine. So we know that 1 degree amines are better than ammonia, better than aromatic. So that's going to be your best option. This is not an aromatic amine, although it has aromatic ring in there. Right. Okay. Moving on. Which is the most stable structure of acetic acid? Most stable structure of acetic acid is something where most unstable. Most stable would be where a proper structure with no violation of octet rule and also no charges. So 1 is the most stable. Okay, extremely good. Okay, now going on to the most unstable. When you look at it, in the double bond on the oxygen electron எடுத்துக்கலாம் இல்லனா carbon electron எடுத்துக்கலாம். Scenario 1, let's put it as scenario A, scenario B. Carbon electron எடுத்தா carbon மேல negative sign வரும், oxygenல positive sign வரும். This is scenario A. Oxygen எடுத்தா இது வரும். Okay. The other one would be where this electron is donated and this one is withdrawing. That's your scenario C. That's this one. Okay. Now when you look at it, the most unstable structure is where the least electronegative atom has the negative charge. See, in the oxygen is negative charge, okay. In the oxygen is negative charge, okay. But here the negative charge is on the least electronegative atom. Carbon oxygen, oxygen is electronegative but having a positive sign, and the less electronegative atom having a negative sign. So this is going to be your most unstable structure, number 4. Fifth one, which is most acidic. So all of them are benzoic acid. Okay. Now, when you have benzoic, it's a special case where benzoic acid, straightforward take for right now, I'll explain this later in detail. Any time in the ortho position, you have a bulky group. Okay, just like this one. If you have a bulky group in ortho, the COOH will go out of plane and become more acidic. This is called ortho effect. In which compound lone pair of electrons or nitrogen is localized. Localized means resonance la illa adu. Delocalized na nariya edathila irukku. Okay, for example, when you take this, okay, this is delocalized because it goes into the ring. Okay, similarly here this goes into the ring 2 2 2 6 pi electrons. So idu ring ulla poradnala aromaticity varudhu. So this is heavily delocalized, this is delocalized. Here also this is delocalized. Okay, when you take pyridine, it's a special case where you want to remember there is 2 plus 2 plus 2 6 pi electrons in the ring. In the rendu electron kudutha 6 pi into the 8 pi maaridum. 6 pi is aromatic, 8 pi is not. So this will be the one that is heavily localized. Okay, localized அப்படினா இது நடக்காதுன்னு அர்த்தம். Okay, or ரொம்ப கம்மியா நடக்குது. Because this cannot go into the ring, this can be donated outside. Okay, hence it behaves as a Lewis base. Lot of reactions, pyridine is used as a basic solvent because of this. It's a basic solvent, whereas aniline is not a basic solvent. Aniline is actually in conjugation. Okay, which does not show hyperconjugation. Hyperconjugation காட்டணும் அப்படினா உங்களுக்கு alpha hydrogen இருக்கணும். Okay, when you look at it, we know that this double bond has here 2 alpha hydrogens and 2 alpha hydrogens. Toluene, we have seen that this double bond can be in conjugation with this 3 alpha hydrogens. Ethyl benzene நம்ம பார்த்தோம் in the previous hyperconjugation lecture, 2 alpha hydrogens, whereas this one, okay, this cannot be in proper hyperconjugation because there is no way this bond is going to be broken and you're going to get this. Okay, oxygen மேல plus charge, இதுல minus charge வராது. So this is not going to show hyperconjugation. Which atom of nitrogen in LSD? This is a drug. It's a contraband drug in India and also mostly abroad. Which of them is most basic? Most basic means அந்த electron easier தரணும். This electron has to be given away easily, meaning it behaves as a Lewis base. Conjugation இருந்தா தராது. So when you look at this one, this electron is in conjugation with oxygen. So this is not going to be given. This electron is in conjugation with a ring and in conjugation with this double bond. So not going to be given easily. Whereas this electron can be easily given. This is just a tertiary amine, 3-degree amine, alkyl. Okay, it's not in conjugation. So this is going to be the most basic, can be easily given. Whereas இதெல்லாம் conjugation இருக்கனால வெளியில கொடுக்காது, உள்ளே கொடுத்துரும். Which of the most reactive towards electrophilic aromatic substitution? Electrophile is going to come into the ring. Okay, it's going to see where lot of electrons are there. So OH is plus R group, OR is plus R group, CH3 is hyperconjugation group, NO2 is minus R. So obviously this is not going to be the case. Resonance is better than hyperconjugation. This is not going to be the case. You want to remember OH is better in terms of giving electrons than OR because of steric effect. OR பெருசா இருக்கனால the electron is out of plane, it cannot give into the ring. So you always want to remember phenol is better than ether. This exception has come so many times in NEET, so you always want to remember. So this is the best, and the order would be 1 is better than 2, better than 3, better than 4. Arrange the following carbanion in order of decreasing order of stability. Okay, they are going to ask them in order of stability. So when you look at it, this is the most stable because this is 2, 2, 2, 6 pi electron aromatic. So this is going to be most stable. So S is the most stable. So this and this are not options. S is the most stable. Okay. Now let's look into the other ones. Whenever you have phenyl ring, we saw this example just some time before. Phenyl ring irundhathu appadina, let's me draw this. CH2 minus, the minus can come here, this can go here, or this can go here, or this can go here. So extended conjugation. So my S is greater than Q. S is greater than Q. Not useful yet. I need to do P and R. Okay, P and R. Now when you look at it, this is called vinyl. Is vinyl stable to an extent only because of one reason. Inge oru sigma bond, inge oru sigma bond, inge oru lone pair. So sp2 hybridization, S character is a little bit higher than normal sp3. So vinyl. Whereas this is called allyl. Allyl means it's in conjugation. Okay, conjugation is always better. So S greater than Q greater than R greater than P. Option Charlie. Among the following, the strongest acid is. Strongest acid அப்படினா hydrogen கொடுக்கணும். What you have here is BH plus giving you B plus hydrogen plus. That means it is strongest acid இருக்கணும்னா it is weakest base இருக்கணும். Okay, that's how they are asking you. Now when you look at it, look at the corresponding bases. CH3NH2, C6H5NH2 is a ring, benzene ring, okay, nitroaniline, and this is going to be CNH2, double bond NH, single bond NH2. Okay, so now look at it. Let's leave Charlie for now. Look at 1, 2 and 3. Which is the best base here? Alkyl is the best base. Basic character is 1 greater than, okay, Now when you look at this, alkyl is really good base, then it is going to be aniline because it is the nitroaniline. Nitro withdraws electrons, so it's not going to be a good base. So 1 greater than 2 greater than 3 in terms of basic nature. Now look at this one. Okay, this one is aliphatic, so obviously it can give, but not as good as 1. And I can get double bond nitrogen irukku. Okay, C double bond NH has become C double bond NH2. Okay, on the lone pair thandirukku, but still it is aliphatic, so it can give not to a great extent. Whereas number 4 is actually like aniline, aromatic, adula vandu minus R effect vara irukku. So it is not going to be best base. Okay, not the best base means இது not the best base, it's a weak base means இதோட conjugate வந்து strong acid ஆ இருக்கணும். Okay, ஏன்னா இது base ஹைட்ரஜனை கொடுக்க விரும்பல, சாரி அக்செப்ட் பண்ண விரும்பல, ஹைட்ரஜனை அக்செப்ட் பண்ண விரும்பல, அக்செப்ட் பண்ணா இந்த பக்கம் போகுது. Okay, it's not wanting to accept the hydrogen, meaning accept பண்ணிட்டா திருப்பி வர விரும்பும். So it behaves as a strong acid. These are new compared to your regular school syllabus, but this is the level at which it has been asked in NEET. This is again an easy question. The way it is worded is different. The bond dissociation energy of CH bond. CH bond நீங்க உடைக்க போறீங்க. Okay. Bond dissociation energy is inversely proportional to the bond strength, length. Okay, bond length அதிகமாக bond dissociation கம்மியா போடணும். is directly proportional to strength. Alright, இங்க வந்து length வச்சு பார்க்க வேண்டாம், strength வச்சு பார்க்கலாம். Okay, or most importantly, this question is easier if you look at what if I break the bond. Okay, CH bond உடையுது அப்படின்னா you will get C minus and H plus. Okay, let's draw the C minus. இது உடைஞ்சதுன்னா C minus இங்க வரும். Okay, which is the best one to equip this negative sign? That's all they're asking. When you look at it right away, I can say my R is the best, correct? Because R வந்து இந்த hydrogen உடைஞ்சிருச்சுன்னா minus charge, allyl, so this is in resonance, so R is the best. R is the easiest to break, okay, meaning lowest bond dissociation energy. So either this is correct or this is correct, this is wrong and this is wrong. I just have to figure out where the rest of them are. Now look at this one. This is methyl, this is ethyl, this is phenyl. At least this is going to be sp2 hybridized. So this is at least a little bit better. Okay, this is a little bit better, meaning in the bond நம்ம ஈஸியா உடைக்கலாம். Okay, first இதுல bond ஈஸியா உடைக்கலாம், அடுத்தது இதுல bond ஈஸியா உடைக்கலாம். Okay, நம்ம bond ஈஸியா உடைக்கிறோம்னா bond dissociation energy கம்மியா இருக்கும். So R ல தான் கம்மி, அடுத்து S ல கம்மி, R ல கம்மி, அடுத்து S ல கம்மி. So that's what you have. Okay, now it will be easy when I draw this CH3 minus, CH3 CH2 minus. Okay, now imagine this is plus I group, electron தரும். இங்க ஏற்கனவே எனக்கு extra electron இருக்கு, this is also giving electron, this is not going to be stabilized, so my Q is less stable than my P. So because it is less stable, okay, I don't want this to be formed. அப்போ அந்த bond உடைக்கிறது கஷ்டமா இருக்கும். So highest bond dissociation energy. Which one of the following is most reactive towards electrophilic attack? Electrophilic means electrophile is going to come. Okay, now this is just similar to before. Electrophilic attack means you have to like what are the effects of this group. This is plus R minus I. For halogens I told you want to look at minus I. This is minus R minus I. This is CH2 is alkyl group, so hyperconjugation plus I but decreased plus I because of OH group. This oxygen is not in conjugation with a ring like phenol. Okay, ஒரு கார்பன் தள்ளி இருக்கு, அதனால இது plus R இருக்க வாய்ப்பு இல்லை. Electrophilic attack means I like my plus R very much, so alpha is the right option. Consider the carboxylic acids. Which of the following is the correct order of acidic strength? Okay, so the more the NO2 groups that you are going to put, the more it is going to get acidic. Okay, that's one. Second thing is just ortho effect we saw. Ortho nitro means this will be out of plane. Alright, so this is going to be much more acidic. So nitro group is minus R minus I in ortho para positions. So my ortho and para are going to win the race. Among them, okay, you want to look at ortho better because of ortho effect. 2 is greater than 3 right there. Then nitrobenzoic acid better than benzoic acid, 4 greater than 1. Okay, again nitro போட்டா உங்களுக்கு acidity அதிகமாகும். So my 1 is the last. Alright, among them ortho and para are in conjugation minus R effect. Now here ortho will win, okay, because of ortho effect and also minus I effect. Correct order of free radical allylic substitution. Allylic substitution means alpha position. Okay, இதுக்கு alpha position இங்க free radical வரப்போகுது. Just put a dot here. Free radical வந்ததுனா எங்கெல்லாம் வரும் அப்படின்னு. Okay, these are the free radicals going to be formed. Which is the most stable free radical? This is a benzylic free radical plus R effect of the ring. The free radical is in conjugation with the ring. This is allylic free radical. This is allylic. Allylic na double bond, single bond, alpha carbon. Allylic. In the free radical number of alpha hydrogen பாருங்க. இங்கே 3, இங்கே 3, இங்கே 1. So there is 7 alpha hydrogens, meaning 7 hyperconjugated structures. Here there is only 3 alpha hydrogens, meaning 3 hyperconjugated structures. So this one is going to be resonance 3 better than 2 better than 1. 16. Among the following compounds, the one that is most reactive towards electrophilic nitration is electrophile வரப்போகுது. Okay, you want to look at the plus R effect, if not plus R hyperconjugation, illana plus I effect பார்க்கணும். Now when you look at it, which one has the most among them? Okay, toluene is the best because it has hyperconjugation. Okay, so that is going to be your best effect possible. The order in which it is going to be is 1 greater than, 2 greater than, 3 greater than 4. No effect, minus R, strong minus R. 17. In chlorobenzene, para-nitrochlorobenzene and 2,4 dinitrochlorobenzene. Okay, so chlorobenzene, para-nitrochlorobenzene, 2,4 dinitrochlorobenzene. The order of reactive towards electrophilic substitution reaction is electrophilic substitution reaction. This is minus I group. Okay, this is minus I minus R minus I minus R. So electrophilic substitution பண்ணனும் அப்படினா, okay, you want a ring to be electron rich. So obviously this is going to be 1 is going to be more electron rich than 2, which is going to be more electron rich than 3. Okay, so 1 greater than, 2 greater than 3. Now nucleophilic substitution கேட்டாங்கன்னா order reverse ல இருக்கும். You are going to see that later. Dow's process. Okay. So the products are formed when the following compound is treated with Br2 in presence of FeBr3. Okay. Br2 in presence of FeBr3. At this point, we will see this in detail. At this point, it's a electrophilic aromatic substitution. Br plus generate ஆகும். Br plus generate ஆகும் அப்படின்னா, where will it go? So this is hyperconjugated structures right here. இதோட hyperconjugation ortho and parallel இருக்கும். இதோட hyperconjugation ortho and parallel இருக்கும். Okay, alright. Now they are asking the products formed when these compounds are treated. So where all it will go? So when you take Br2, இது 3 position போக முடியும் உங்களுக்கு. Okay. Now when you look at it, where will it go? When you take this position, Br is a big group. இங்கே போட இடம் இருக்காது, repulsion இருக்கும். So you are not going to get that as the major product. So see, this is not going to be there. This is not going to be there. Okay. So now this is meta position. That is also not going to be favorable. So that's not going to be there. So you're going to have this position and this position right there. That's the major product. Okay. This is going to be a minor product. This and the meta position is going to be minor product. The most stable carbanion, just like before we saw, this is going to be sp3. This is sp2. This will be sp. This will be sp3. Most stable means you want the s character to be high. So this is going to be the most stable carbanion. This is going to play a vital part later in terminal alkyne, where it can answer tolerance and fillings because of this character. We'll expand on that later when we go into alkenes. Okay. Alright. Now, which of the following represents the correct order of stability of the given carbocation? Okay. Now what you want to do is, this is a special cation. This is called tropylium. So again, I am not able to go through all these examples for you because this being a crash course. Year long means I have time for everything. Crash course means I will introduce as and when we see the examples. This is tropylium carbocation, 2, 4, 6 pi electrons, and also they are in conjugation. Okay, double, single, double, single, double, single, charge, single, double. So it's in conjugation. So this is the most stable carbocation. 3 is the most stable. Then we look into this one. This is 2, 2 and in last example பார்த்தோம் minus இருந்தா stable இருக்கும். So we saw this as the last example, previous sheet. 2, 2, 2, 6 pi electrons. So cyclopentadienyl carbanion is aromatic. Tropylium is aromatic, but this is not aromatic. Okay, this is actually anti-aromatic. Okay, we'll worry about that later. But at least I know that this is not really good, whereas this one is benzylic. Benzylic means it can be stabilized through all these. So my 3 is better than 1, okay, which is better than 2. Again, remember this is important. Tropylium is very stable. The order of increasing reactivity towards electrophilic reagent for the following would be: benzene is our reference, toluene na hyperconjugation இருக்கும், chlorobenzene na minus I இருக்கும், phenol na plus R இருக்கும். So obviously B is better than hyperconjugation, B is better than B, which is better than A, better than C. Okay, again I'm going fast. You have to get to that level. In the compound எல்லாமே நீங்க வரைய கூடாது. திருப்பி பார்க்கறதுனால you should be able to right away look at it and say phenol is better than ether, ether is better than toluene, toluene is better than benzene, benzene is better than chlorobenzene. That speed you have to get eventually. Okay, 22. In isobutane, the most stable radicals formed in homolysis. So isobutane, let's draw this. Now we are going to draw radicals. Okay, radical is going to be formed, meaning a carbon hydrogen bond is broken. Homolysis meaning carbon takes 1 electron and hydrogen takes 1 electron. How many different positions are there? In the carbon, in the carbon, in the carbon, மூணுமே ஒண்ணுதான். Okay, they are the same. Okay, this carbon is different. So this carbon hydrogen bond is different than this carbon hydrogen bond. So let's take case 1 and case 2. In case 1, if I break, I get this. If case 2, I get this. Which one is more stable? Obviously this one, because it has 3, 3, 3, 9 alpha hydrogen, meaning 9 hyperconjugated structures. This one has only 1 alpha hydrogen. So this is the best one possible. So you're going to have this. Homolysis. Homolysis means they break evenly. Okay, carbon hydrogen bond irukna, carbon ku or electron, hydrogen ku or electron. Heterolysis means one of the atom takes both the electron, just like this. Okay, all right. So they are asking about homolysis, means I'm talking about carbon, the free radical. So beta is the option. If it is heterolysis, this would have been the option. The most stable carbocation is. So now when you take this carbocation, it has 3 plus 3, 6 alpha hydrogens. When you take this one, there is 3 and 2, total 5 alpha hydrogens. So this one has 3 plus 2, 5 alpha hydrogens. This one has 2 plus 2, 4 alpha hydrogens. Okay, so obviously when you look at it, this one is going to be the most stable one. Alright, so the order would be 1 greater than, so 2 and 3 ku pathina rendume 5. Okay, then we look into inductive effect. This one will have a larger inductive effect than this one. Metal renduthliyum onna irukum. So 1 greater than, 3 greater than, 2 greater than 4. Okay, the most stable alkene, again we are coming down to hyperconjugation. Most stable alkene means should have the lot of alpha hydrogens and also conjugation. When you look at this, double single double conjugation irukku, double single double conjugation irukku. So these two have extended conjugation. whereas இது வந்து வெறும் double bond இருக்கு, conjugation இல்ல. So this, let's look at this one. In the double bond க்கு இதுவும் alpha. Okay, this has one hydrogen, this has 3 hydrogens. So this double bond has 4 alpha hydrogens. This double bond, when you look at it, okay, when you take this double bond, this has no alpha hydrogens on this side, correct? So there is no alpha hydrogen. So total 4 alpha hydrogens. When you take this double bond, this is alpha. Okay, this is 1 alpha hydrogen. In the double bond, it is alpha, 1 alpha, 2 alpha hydrogens. Alright. So now between these two, இது ரெண்டுல ரெசனன்ஸ் இருக்கு. இது ரெண்டுல கம்பேர் பண்ணா ஆல்பா ஹைட்ரஜன் மட்டும் எடுத்தா இங்க 2 இருக்கு. இதுக்கு வந்து இங்க 3, இங்க 3. Okay. So your double bond, single bond conjugation wins. So my 2 and 3 are greater than 1 and 4. Okay. Now among 2 and 3, you know that this has more alpha hydrogen. So 2 is the most stable, more substituted alkene. 2 is the best, followed by 3. ரெண்டுத்துலயுமே I have double, single, double conjugation, better than just alpha hyperconjugation. Now between 1 and 4, okay, now when you look at it, my 4 is better than 1 because more number of alpha hydrogens. Which of one of the following is an ortho-para-directing group for electrophilic? Okay, ortho-para-directing group meaning it has to have plus R effect. This is minus R, this is minus R, this is minus R. Meta-directing, this is plus R. The decreasing order of minus I effect, I have given the order for you. 1 is greater than 3 greater than 2. This is straight out of the worksheet I sent you. 7. The number of hyperconjugation structures possible in toluene is. Now here this is toluene. There are 3 alpha hydrogens, so you can answer 3. Now if we take this with 3 in the ortho, 3 in the para, 3 in the ortho again, that will be 9. So either this is one option, this is one option. NEET la kuduthangana, both will be correct. So 9 is also an option. So this 3 is in conjugation with the ortho is 3. Para is 3, another ortho is 3. Pyridine is less basic than triethylamine. So triethylamine is NET, NET, NET. This is a 3 degree amine. We know the 3 degree amines are more basic than ammonia, which is more basic than aniline. We have seen this before. Okay, now they are asking about pyridine. This is pyridine. Okay, it is less basic than triethylamine because, so when you look at it, pyridine has aromatic character. This is true, but that's not the reason why it is less basic. The nitrogen in pyridine is sp2 hybridized. Nitrogen here is, look at it, 1 sigma, 2 sigma, 3 sigma bonds plus 1 lone pair. Is 4, meaning S1P3, sp3 hybridization. In pyridine I have 2 sigma bonds and 1 lone pair. Total 3 electron pairs, so that is sp2 hybridization. S character is 33%, S character is 25%. S character அதிகமா இருந்தா electronegativity அதிகம், basicity கம்மி. So this seems like this is a correct option but not the correct reason. This seems like correct option and correct reason. Pyridine is a cyclic system, true but not the correct reason. So what? In pyridine, lone pair of electron is delocalized. The option itself is wrong because this is localized. We have seen in the previous one also. So beta. Alright. Most stable carbocation. So you want carbocation to be benzylic. Benzylic, 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 benzylic. எல்லாமே ஒண்ணா இருக்கு. Okay, you want it to be stabilized by plus R effect. So when you look at this one, this is plus R. This is plus R. No effect. Inga hyperconjugation இருக்கு. Okay, so plus R is better. What about OCH3 in terms of, if it is plus R, what else do you get? You get minus I in ortho, whereas you don't get I. So this is going to be most stable because not only it has plus R, it also has hyperconjugation. This one has plus R but also has minus I. So my D is greater than B, which is greater than my C because it has hyperconjugation, which is greater than my A. Number 30. The order of reactivity towards an electrophilic reagent. So we know that Okay, benzene is going to be hyperconjugation, phenol is plus R, chlorobenzene is minus I, benzene is neutral. So my D is going to be greater than B greater than A greater than C. Cyclohexanol, acetic acid, trinitrophenol, and phenol. We are asking about decreasing order of acidic character. Okay, that's about decreasing order of acidic character 1, 2, and 3. Let's see, 1 I have written down correctly, 2 I have written down. Okay, now when you think about it, what is the one that is least acidic among them is the easiest to figure out. That's going to be your cyclohexanol. Another acid கிடையாது. So this is the wrong option. Okay, now I know this is an acid, this is also called picric acid. So my delta is going to be there last but one. Okay, last க்கு முன்னாடி. So இது option இருக்க முடியாது. So these two are okay. Now between 3 and 2, okay, this I have to give you the values. Okay, in our case picric acid will be stronger than acetic acid. Okay, formic acid is still stronger than picric acid. So formic acid stronger than picric acid, stronger than acetic acid. So here they are asking you this. So my 3 is greater than 2 alpha. The order of stability of the carbocation. Okay, carbocation is given in all of them. Stability is when there is a resonance, it's going to be more stable. So when you look at this one has plus R effect right away. Okay, this is there, but it cannot give to carbocation, it gives far away. So this is just minus I effect. This is also minus I effect. This can give, okay, this can give, this is minus I effect. This one cannot give because two single bonds, so this is minus I. So when you look at it, the best ones are, okay, 4, 5 and 3. Among them nitrogen can give the best, so 5 is the best. So that's going to take care of this one. Now when you see 5 is best, 3 and 4 and 3 ரெண்டுமே மாத்தி மாத்தி இருக்கும். Okay, now I need to 3 or 4. Alright, now this is a little tricky because we don't know the effect exactly. Okay, but this is going to give electron. This is plus I group also, but is there a steric reason? We don't know yet, but let's look at the other options. Let's look at the worst one to see which is going to be really, really bad. Look at number 6, direct minus, okay, direct minus I. So this is going to be the worst. So this seems like this option. Let's see. My 5 is the best, then they say 4 is the best, then they say 3. So there is steric reason of the big group. Okay, so this is okay, this is okay, this is okay. Then there is 2. Okay, minus I of this one is obviously lower than minus I of oxygen. Fair enough. Which is lower than minus I of NO2. NO2 is one of strong minus I. Okay, which is lower than this. Okay, actually this is a really good question for you to practice everything together to understand your effects. It gives you an order of minus I group. Okay, so it's a very good question. You can practice it yourself as well. 33. The order of reactivity of hydrogen atoms towards free radical substitution. Free radical substitution means and the hydrogen போயிடுச்சுனா radical will come. Either I will get this radical if this hydrogen goes away, this radical if this hydrogen goes away, and this radical, this radical. Okay, when you look at it, double bond க்கு அடுத்த கார்பன்ல இருக்க ரெண்டுமே ஆல்பா வந்து அலைலிக். It's in resonance. Lone pair single bond, lone electron single bond double bond, or lone electron single bond double bond. So my 2 and 4 are really good. Okay, 2 and 4 are really good. Among 2 and 4, when you take this one, in this side allylic irukku. Okay, let's take 4. This side there is double bond to stabilize. What about this side? There is 2 hydrogens, so 2 alpha hydrogens. Whereas when I take this one, okay, there is 2 alpha hydrogens here and 3 alpha hydrogens here. So number of alpha hydrogen for 2 is higher. So 2 is greater than 4. 2 is greater than 4, 2 is greater than 4. Okay, these two are wrong. Alright, now I have to decide between 5 and 6. That will tell me the entire order. 5 and 6. When you look at 5 and 6, they kind of look the same. Okay, let's erase it now. Now we know that so far we have figured out 2 is greater than 4, 5 and 6, 5 and 6. Okay, now when you look at 5, okay, there is 2 this side alpha hydrogens and 2 this side. So 5 has 4 alpha hydrogen. 6 எடுத்தீங்கன்னா 6க்கு இந்த பக்கம் 2 alpha hydrogens இங்க இருக்கு. இங்க போனீங்கன்னா ஒரே ஒரு alpha hydrogen தான். So this has 3 alpha hydrogens. So I know my 5 is better than 6. 2 greater than 4 greater than 5 greater than 6. Now between 1 and 3, let's see whether it justifies. இப்போ 1 எடுத்துக்கிட்டீங்கன்னா, okay, இங்க வந்ததுன்னா there is 1 alpha hydrogen, okay, and the hybridization is sp3, whereas இங்க போட்டீங்கன்னா double bond இருக்கு, double bond is sp2, so obviously 3 is the last one, so 2 is the best option. 34. In the given reaction, A and B respectively are Cl plus is a electrophile. Electrophile போனோம் அப்படின்னா இது plus R group. This is a plus R group. This is a plus R group. Minus I, minus I. அப்ப எங்க போகும் அப்படின்னா plus R group இந்த ortho is good. Okay, இதோட plus R இங்க தான். ரெண்டு plus R இங்க வருது. This position. Similarly, இதுக்கு இது ortho, இதுக்கு இது para. So ரெண்டுத்துலயுமே plus R இருக்கும். Okay, plus R of NH2 is better. Minus I of NH2 is weaker. But minus I of OH is stronger. அப்ப இங்க minus I of OH is stronger. இங்க minus I of NH2 weaker. So அப்ப இங்க electrons அதிகமா இருக்கும். Okay, compared to this position. So my Cl goes to the position ortho to NH2. So Cl goes to position ortho to NH2 right there. Okay. Now what happens to the next one, NO2Cl? Now obviously it will go to ortho to OH because para to OH ல வந்து இதோட minus ஆரும், ortho to OH ல இதோட minus ஆர் இருக்கும். That's same. Okay, let me take an example of this and write all of them. Let's say one by one. இது minus R, minus I. So I will feel the minus R here, minus I here, minus R here. Okay, sorry, plus R. This is plus R, minus I. So I'll feel the plus R here, I'll feel the minus I here, I'll feel the plus R of OH here. Now I'm going to do NH2. NH2 is what type of group? Plus R, minus I. இப்போ இந்த NH2 ஓட plus R இங்க இருக்கும், minus I இங்க இருக்கும். The NH2 ஓட obviously இங்க minus I இருக்கும், ரெண்டுத்தோட minus I. I'm not interested in the minus I alone. இந்த NH2 ஓட plus R இங்க இருக்கும். Okay, இந்த கேஸ்ல NO2 is minus R minus I. So I will feel the minus R here, minus I here. இந்த பொசிஷன்ல minus R இருக்கும். Okay, now going to weighted average. Going to first example. Okay, இங்க minus I மட்டும் தான் இருக்கு, so I don't want this. Okay, when you look at here, plus R plus R plus R plus R, minus I, ரெண்டு plus R மே equal தான், ஆனா OH ஓட minus I is stronger. Okay, so இங்க electron கம்மியா இருக்கும், whereas minus I of NH2 is weaker. அப்ப இங்க electron நிறைய இருக்கும். Also plus R of NH2 is higher than OH, but it fills in both places same. So this position இங்க போகும்போது எனக்கு இங்க plus R இருக்கு, minus R இருக்கு, the R's cancel out. When you take minus I of OH, okay, is weaker compared to minus I of this. So there is electrons here, but there is more electron here. So I will have ortho to NH2 and ortho to Cl. Alright, the most stable among the following. See here I have double bond, single bond, double bond. Right there I have conjugation. So this is going to be most stable. If you want to do the other ones, okay, this one has 3 alpha hydrogens here, 3 here and 2 here. இதை எடுத்துக்கிட்டீங்கன்னா இங்க 3 இருக்கு, இங்க 2 இருக்கு. இதுக்கு alpha hydrogen இந்த பக்கம் 3, இந்த பக்கம் 3. So my A is better than my B. Now there is between these two, when I look at it, this has 3 plus 2, 5, 3 plus 3. So C greater than D. Increasing order of electrophilic substitution for the following compounds. So this is plus R, hyperconjugation, minus I, neutral. So obviously my 3 greater than, 2 greater than, 1 greater than 4. 3 greater than, 2 greater than, 1 greater than 4, alpha. The basic strength of the following. Okay, basic strength meaning behaving as a good base. நல்ல பேஸா இருக்கு அப்படின்னா it's unstable இருக்கணும். And unstable, I want to react faster. We saw this example before. This is sp carbon, sp2 carbon, sp3 carbon. S character அதிகமா இருந்தா stability of anion அதிகம். இப்போ இது most stable compared to these two. இது stability அதிகமா இருந்தா basicity கம்மியா இருக்கும். Okay, so this is going to be the most basic. So 1 is greater than, 2 greater than 3. This one. So there's a sign missing here. 1 greater than, 2 greater than 3. Increasing order of stability. Okay. Now when you see there is triphenyl, or let's put it this way. Dot. This electron can come here. This is benzylic. Adile 3 ring is extremely stable, better than 2 rings, better than 1 ring. Okay, better than this one. This has 9 alpha hydrogen. This has H means it has about 3 plus 3, 6 alpha hydrogens. Okay, so this is the order. Benzylic is better. Adile tribenzylic is better than dibenzylic. Then your alpha hydrogens. The correct order of reactivity towards electrophilic substitution of aniline, benzene, nitrobenzene. Aniline is plus R, benzene is neutral, nitrobenzene is minus R. So obviously 1 greater than, 2 greater than 3. Which one of the following compound is most acidic? Okay, we have regular alcohol not going to be most acidic. Obviously phenols are better. Okay, adula vandu idu plus R hyperconjugation group, electron ulla kudukka podu, and also plus I. Electron ulla tara in the OH bond acidic மாறாது. You want minus R group to be attached. This is a minus R group. Okay, so this is the best. Okay, so you will have 1 greater than 3, which is a regular one, compared to 2 greater than 4. Okay, alright guys, hope you understood a little bit. Now I know that this is difficult. That's how most year-long students also feel, but they have time to work on it. When you enna pananuna திருப்பி again print this worksheet, do it one more time, you will do better. And then after 2 weeks or so, take this again, do it again, same sheet, இதே examples போதும். Same examples will be repeated in NEET over and over again. Your job is 2 things. One is to understand this concept, and second thing is get speed. Speed comes only with practice. Okay, alright, thank you guys.